So the definition of a chord is a segment with both endpoints on the circle. Okay, but it is not a diameter. Okay, diameter goes specifically through the center of the circle, a chord does not. So if you draw a segment from one part of the circle to another, we'll call that PQ. You do have to be specific with notation. And since a chord is just a segment, if you're talking about the chord, then we'd use the segment notation. Okay. If you're talking about the arc that's related to that chord, you use the arc notation. So make sure you're specific because we're going to be dealing with both in this homework, and if it appears on a quiz or a test, you have to use the proper notation. All right, so I think what we're going to do is we're going to actually talk about some of the theorems first, and then we're going to pick out some homework problems that relate to the theorems. Okay, so we're not going to do the examples with each theorem. We'll get through those and then we'll pick them apart a little bit. Okay. Or actually we can. We'll do some of the homework problems with the theorem they go with. So in a circle or congruent circles, okay, so we'll assume these two circles are congruent. If central angles are congruent, okay. If the central angles are congruent, and I want you to draw the chord in between B and C and E and F. Congruent central angles give us congruent chords, so the chords will be congruent. And the corresponding arcs will be congruent. Okay, so the chords, we would say BC is congruent to EF, the two segments. And for the arcs, we'd say arc BC is congruent to arc EF. Okay, so you can mark those congruent, and we'll use 2 for the arc. Okay, now I'm using the marks for the arc very lightly because we're not talking arc lengths, we're talking arc measures. But let me ask you this. If the circles are congruent, of course arcs can be congruent with 2 circles that are not. But if the circles are congruent, would my arc lengths be congruent as well? What do you think? If 2 circles are congruent, and we're talking about arc lengths and not just arc measures, would those be congruent? Yeah. If the circles are congruent, then the corresponding arc lengths would even be congruent. So not just the measures, but the lengths as well. All right. Okay, another theorem. Within a circle, or congruent circles, chords that are equidistant from the center are congruent. The converse works as well. Chords that are congruent are equidistant from the center. So it works both ways. All right. Makes more sense when you see the diagram what specifically you're looking for. When we talk about the length between the center and the chord, we need the perpendicular distance, okay? So it can't just be, I can't go from here to here and talk about that length. It's got to be perpendicular, you know, basically if the radius were perpendicular to the chord, that distance is what we're talking about. So if these are both perpendicular and those are congruent, and I'm going to give you a measure for these only because it's hard to use the tick marks when we've got halves and things like that going on. So we'll say if that's 8, then that should be 8. Okay. So if I see that these are congruent, then those chords should be congruent. If I see that the chords are congruent, then these two lengths should be congruent. These are very quick homework problems because you're not, for a lot of these types, you're not really doing much in the way of calculation. You might double something or take half of something. Okay. So we'll get to some examples of these in a moment. But there are a couple, there's one other theorem. If a diameter is is perpendicular to a chord, then it bisects the chord and the arc. The converse also works. If a diameter bisects the chord and arc, then it is perpendicular to the chord. Corresponding drawing would be here, draw a diameter and draw a chord that is perpendicular. Okay, so if you've got a diameter and a perpendicular, we know that these are congruent, and we also know that those are congruent, and vice versa. Now just be careful on these that you don't assume all three. If you don't know anything, if I see a diameter and a chord, it means nothing unless I have something either that's congruent or perpendicular, okay? So don't make assumptions just because something looks like that. You have to have at least one piece of information to lead to the others, okay? So we're going to do some of the homework problems to walk you through what these look like. Number 1,
them the same size.
Yep, try and make them the same size. I mean, so, knowing that the circles are congruent, they're going to ask, what can you conclude? 1 and 2 are the same types of questions. Okay, with congruent circles, if I know the angles are congruent, then what else do I know? What's that? The chords are congruent, so the answer, one of the answers would be BC is congruent to YZ. And anything else? Of what? The arcs. The arcs are congruent as well. Okay. Now, one of the things you will run into, and this is why the theorem says within a circle or congruent circles, okay, it doesn't have to be 2 separate circles. Okay, if that's the center of my circle, okay, I could say, I know that those are congruent, right? You don't even have to mark those are vertical angles. But if I put some chords in here, that would be an example of what we're doing there, except it's within the same circle, okay? All right, we'll do number 8. All right. First of all, if they put the number in the middle of the segment, they're not talking about one half or the other. So if it's right smack in the center, they're talking about the whole segment. Oh, let's change that though, because number 8, they're talking about that half. So using the theorem, our chords are equidistant from the center, so what does that mean? Chords should be congruent, right? So what would the length of X be? 10. Because if this is 5, that's 5, the whole chord would be 10, so X should be 10. Like I said, not a whole lot of calculation that you have to do. Let's look at 11. Yes. Okay, if you're looking for X, the first thing you should notice is X is a leg of a right triangle, right? And, oh, let me give you that. That's a pretty important part. So 18 would be the whole chord. Now this has to do with if the radius, so to speak, is perpendicular to the chord, it bisects it, right? We need to know that because you can't assume that it would come in at half unless you have the perpendicular. So if it's perpendicular, we can say that that's 8. These are radius because it's a diameter, so each of these would be 10. So what would you do to solve for X? Pythagorean theorem. Or if you're paying close attention on this one, 8 is twice 2 times 4, 10 is 2 times 5, so the other side should be 2 times 3, right? It's a 3, 4, 5, doubled. So X is 6. If you didn't know that, you would do X squared plus 8 squared equals 100, or sorry, 10 squared, and then you'd solve and find out that x is 6. All right, there's a couple that I want to point out to you. I'm not going to do them for you, but there's some critical information here.